And see, so again, today's gonna be really short. We're just going over how to graph a polynomial function without actually using a graphing calculator. And we don't really focus on polynomials past the past the cubic function. In pre-cal, you will dive deeper into that realm of polynomials. But here we go. So we've been graphing linear and quadratic functions for a while now. It's the same process for graphing and analyzing all other polynomial functions. So steps to graph without a graphing calculator: we create a table, choose an appropriate domain for the function, try to include some negative numbers and values that do not produce decimals if possible. Then we create the graph using the values in the table, and then we should be able to analyze the graph, say what's the domain, the range, the turning points, the increasing and decreasing intervals, and end behavior. Okay, so that's ultimately our goal. So we're going to start here with this polynomial, y equals 1/2 x cubed. So clearly this is a cubic. This is a cubic function. Okay, so with cubic function, we have certain shapes that we kind of lean towards. Either, if you remember from our notes yesterday, they are either forever increasing or they have some turning points in them, right? So these are our typical two shapes of our cubic function. If I have 1/2 x cubed, when I create my table, I'm going to have 0, right? That's easy enough. And we can have -1, -2, and let's do -4. Even numbers, except 1. 1, 2, and 4. So when you're filling in the table, all you're saying is if I plug these values in, what is my output? So if I have 1/2 times -4 to the third, what is that going to equal? Well, -4 to the third is -64, and half of -64 is -32. Next, we have -2. I have 1/2, -2 to the third. -2 to the third is -8. Half of -8 is -4. Then I have 1/2, -1 to the third. -1 to the third is -1. Half of -1 is a half. -1/2, sorry. 0, well, that's easy. It's going to be 0. And because these are just the opposites of my original inputs, it's going to be the same except positive values, right? So I'm going to have a +1/2, I'm going to have a +4, and a +32. All right, -4 would be kind of difficult to graph, so we can't graph that, but we can graph -2. So I go to -2, I'm going to go down to -4, 1, 2, 3, 4. Sorry, on the printout, for some reason your lines did not print. I have no earthly clue why. They were maybe too faint. On -1/2, so I'm going to go to -1, go to 1/2, 0, 0, 1/2, and 2, 4. 1, 2, 3, 4. And now I have them, so I'm going to create the graph by connecting them. And again, -4 is going all the way down. So I know the graph is going to be going all the way down. That was a horrible attempt of connecting, y'all. Horrible. Horrible. Let's try that again. That one's better. Yeah, there we go. So there's my graph, and now I can analyze the graph. So analyzing this graph, my domain. What's the domain of this graph? It's all real numbers, right? It goes on forever. It goes on from negative infinity to positive infinity. It's all real numbers. What's the range of my graph? Same thing. Goes on forever. From negative infinity to positive infinity. All real numbers. My increasing interval. So if I look here, I'm increasing, I'm increasing, I'm increasing. So my increasing interval is all values of x, right? So that means forever I'm increasing. So from negative infinity to positive infinity, all values of x. And I have no decreasing intervals. My end behavior. So looking at my end behavior for us, we just need to say, is it going down or up? So starting on the left, I'm heading towards negative infinity. So that means it's going down. On the right, I'm heading towards positive infinity. So it means it's going up. And because I'm forever increasing, there are no turning points. What are your questions about creating the graph? Doable? Is it any different than what we did for linear or absolute value or cubic? Nope, same process. All right, here we have 3x minus x cubed. Again, because our highest power is a 3, we know that this is a cubic function. We want to try to use small numbers, so we're going to start with 0, negative 1, negative 2, negative 3, positive 1, positive 2, positive 3. And again, all I'm doing is substituting the values in. So my input is negative 3. So I have 3 times negative 3 is negative 9. Minus negative 3 to the third is negative 27. A negative times a negative is a positive. What is negative 9 plus 27? 18. So we're going to do it again. So negative 2 times 3 is negative 6. Minus negative 2 to the third is negative 8. A negative times a negative is a positive. What is negative 6 plus 8? 2. All right, negative 1 times 3 is negative 3. Minus negative 1 to the third is negative 1. A negative times a negative is a positive. Negative 3 plus 1 is negative 2. And if I plug in 0, it's just going to be 0. So we have 1 times 3 is 3, minus 1 to the third, which is 1. That equals 2. 2 times 3 is 6. 2 to the third is 8. 6 minus 8 equals negative 2. Oh, just change the example. 3. 3 times 3 is 9. Minus 3 to the third, which is 27, which gives me negative 18. All right, so I have everything, and I'm going to graph. So negative 318 will be off the page, but I can do negative 2, 2. So I go to negative 2, 2, 2. I can go to negative 1, negative 2. So negative 1, negative 2. I can go to 0, 0. I can go to 1, 2. And then I can go to 2, negative 2. Do my best to connect them all. It's actually pretty good, I would say. So now we're going to analyze the graph. What's the domain here? All real numbers. What's the range here? all real numbers. Increasing intervals. So where am I increasing and decreasing? So from left to right, just like we read a book, I'm decreasing here, increasing here, decreasing here. So from where to where am I increasing? When we're describing it, we're saying from what x value to what x value. So I increase from -1 to +1. So from -1 to +1, I'm increasing. That's when I have my up. When am I decreasing? Well, here at -1, I'm decreasing to the left of -1. So when x is less than -1, and here at +1, hello, here at +1, I am decreasing to the right. So that's when x is greater than 1. My end behavior, I'm heading towards positive infinity on the left. So that's pointing up. And on the right, I'm heading towards negative infinities. And so that's going down. All right. So based on this, I had a total of 2 turning points. I had a turning point here and a turning point here. Okay. How do we feel? Still good? All right, our last one. So again, looking at the highest power, we see that we still have a cubic. And we're still going to create a table. Let's see. We'll make it a short table. Let's do -1, 0, 1/3, 1, and 2. All right, so we have -1. If I plug -1 in here, what do I get? -1 to the third is negative, so I end up with a 1 plus or minus plus 2 plus 1 minus 2. And that equals 3 plus 1 is 4. 4 minus 2 is 2. 0 is easy. 0, 0, 0, -2. Now, I wanted to do the fraction on purpose because we need practice with fractions. So we're going to plug in 1/3. So what does that look like? So if our input is 1/3, we have -1/3 to the third plus 2 times 1/3 squared minus 1/3 minus 2. So the power goes to the numerator and the denominator. So we end up with -1/9. Meant 1/27. Poopers. So we have -1/27. And then here we have plus 2/9 because 1/3, 1/3 squared is 1/9. 2 times 1/9 is 2/9. Minus 1/3 minus 2. What has to be true to add and subtract fractions? The denominator has to be the same for all of them. So if I look right here, my least common denominator for all these would be 27. Agreed? I'm going to do it here and then erase. I can do it over here. Here we go. So we have negative 1 over 27 plus, and this is going to become 6 over 27 minus 9 over 27 minus 54 over 27. So they all now have a common denominator. And now I just got to add and subtract my numerators. So I have negative 1 plus 6, which is 5. 5 minus 9 is negative 4. Negative 4 minus 54 is negative 58. Which is obviously 2 and some change. 2 and 2/27. There's some fraction practice for us. Fractions are your friends. So this is at negative 2 and 2/27. Had to make today a little challenging. All right, if I plug 1 in, I'm going to get pretty much the same reaction as negative 1, but instead of a positive 2, I'm going to end up with a negative 2. And if I plug 2 in, what's going to happen? Well, 2 to the third is 8, plus 2 squared is 4, times 2 is 8, minus 2, minus 2, and that equals negative 4. Let's see what we can create here. So we have negative 1, 2. We have 0, negative 2. We have 1/3 and some negative 2 and some change. Is that exact? No, it's going to be the day. We have 1, negative 2. We have 1, negative 2, and we have 2, negative 4. 1, 2, 3, 4. So our graph looks like this. All right. Now, let's analyze. So domain, all real numbers. Range, all real numbers. Increasing interval. So I'm increasing. So this is a decrease. Then I have a tiny little increase from here to here. And then I have a decrease. So I'm increasing from at 1/3, because your increasing values are based on your x. So from 1/3 to 1, I increase. So my increasing interval is from 1/3 to 1. My decreasing intervals, I decrease to the left of 1/3. So when x is less than 1/3. And I decrease to the right of 1. So when x is greater than 1. My end behavior, I'm going towards positive infinity on the left. So going up, going towards negative infinity on the right. So I'm going down. Because of the change in direction, it's evident that I have 2 turning points. All right, that concludes cubic functions and graphing them and analyzing them. Any questions, comments, or concerns? All right, so you should be able to complete your classwork that's on camera.